This is a high-speed train capable of reaching over 300 kilometers per hour. But what powers it isn't one giant engine, it's many smaller electric motors. Spread across the underside of the train, these motors produce 75 times more power than a Tesla Roadster. On top, two spring-loaded clamps form what's called a pantograph. It presses against a 25,000-volt overhead cable to supply electricity to those motors. The gears rotate to generate power, driving the hardened wheel cylinders, spinning at more than 1,800 RPM. Under the train, the hardened rails are welded together, so the joints are completely smooth. Running on them are 128 perfectly round hardened wheels, suspended by metal bar springs and shock absorbers that eliminate even the tiniest bumps. To prevent the train from swaying, hydraulic dampers are installed under each carriage to absorb any side-to-side movement, keeping the train ultra-stable even at speeds of 300 kilometers per hour. The train's incredible cornering speed depends on ultra-strong air tanks hidden beneath the chassis. Their impact pressure is 4 times that of car tires. As the train approaches a curve, an electromagnetic valve opens automatically, releasing a large amount of air. These powerful rubber belts capture the air and expand, lifting one side of the 700-ton train, allowing the body to tilt into every turn, so it can maintain high speed even on sharp curves. If an earthquake hits while the train is running, the control center remotely cuts the power. The train loses propulsion, turning the motors into powerful brakes. Anti-derailment guards installed on the tracks prevent the carriages from tipping over, keeping the train on the rails even as the ground shakes. Finally, 128 pneumatic brakes clamp onto the brake discs, bringing the 700-ton machine to a complete stop in just 3 kilometers. And that's not all. High-speed trains also use a regenerative braking system. Before arriving at a station, they don't slow down with air brakes, but by reducing the power of the electric motors, the motors stop driving the wheels and turn into generators, converting wheel movement back into electricity. This slows the train while generating power, which is then sent back through the pantograph into the overhead cable, stored there for the next train to use. Pneumatic brakes are only used during arrivals or emergencies, and that is how a high-speed train works.